In this lesson, we're going to look at compounds made with oxyanions. Now, an oxyanion, as the word suggests, is an ion made from a metal or a non-metal and oxygen. Now in chemistry, the word anion means an ion with negative charge. The word cation means an ion with positive charge. So this type of ion has a negative charge, or a negative oxidation number. Now, despite the fancy name, oxyanions are things that you're very familiar with. You've come across these in many different types of substances, in both acids and in salts. Now, the common oxyanions are these. So you have carbonates, sulfates, sulfites, nitrates and bicarbonates. And you should be familiar with formulas. So the formula for carbonates is CO3, that's for carbon, and oxygen for sulfates, SO4, sulfite, SO3, nitrate, NO3, and bicarbonate, well, that's CO3, and wherever you see the word bi, that means that there's a hydrogen attached to it, so it's HCO3. Now, as I said earlier, these are anions, so we should give a negative charge to each group. So CO3 has -2, SO4 has -2, SO3 -2 is -1. We just put minus there, and HCO3 likewise is minus. So likewise, we can also talk about the oxidation number of the oxyanion. So the oxidation number is the same as the charge on the anion. So in this case, it's -2, -2, -2, -1, and -1. This is the same as the valency, and these are very important, as we'll see later, in working out the formula of a compound from its name. So an oxyanion is an ion, I've got to put that in there, made from a metal, forgot to cross my T there, naughty boy, or a non-metal and oxygen. Okay, it has a negative charge or oxidation number. So let's look at some common substances formed from these oxyanions. So first of all, let's look at how to go from the formula to the name. Well, you know the name of this metal here is calcium, and the oxyanion again is the carbonate ion, something you need to become familiar with. Okay, so that's calcium carbonate, which is a familiar substance. This is found in limestone rock and chalk, for example. A very useful substance in the building trade. This substance, again, if you want to name the substance, you look at first of all the metal, and we recognise that we have sodium, and then the oxyanion is sulfate, so it's sodium sulfate. Now, when we want to go from the name to the formula, things become a little bit more tricky. So what we have to know now is the valency, or the oxidation number, of the oxyanion and the metal involved. So the first thing we do is we write down the symbols for each. So you need to know that the symbol for aluminium is Al, and you need to remember this, that the symbol for the nitrate group is NO3. Now then, what we then have to do is check the valencies. And we get a pencil, and we write the valencies, or the oxidation number, above each group or element. So the oxidation number for aluminium, you can see on the periodic table that aluminium's in group 3, so it has a +3 there. Now, NO3 doesn't appear on the periodic table, so at this stage we need to remember its oxidation number. We need to remember that it's -1. We want the sum of these oxidation numbers to be equal to 0, and so we see that the way we can do that is multiplying this group here, NO3, by 3. So we take brackets here, we put the group inside brackets there, and we multiply that by 3, put a little 3 there, so that means 3 times minus 1 gives us minus 3, okay, times 3, plus 3 gives us 0, so everything is balanced there. So this is the formula for aluminium nitrate. And likewise, we look at potassium sulfate, for example. Well, we write down first of all the symbol for potassium, okay, which is a K. Then we know that the formula for the sulfate group, because we've remembered this, is SO4. You've got to remember that formula. And then you've got to remember what its oxidation number is. So we write down the oxidation numbers. We know that potassium's in group 1, so that has an oxidation number of +1. And the sulfate group, we remember that's -2. It's not that difficult to remember when you think about it, because these common ones, well, you've got carbonate, sulfate and sulfite, they're all -2, all -2. The only one that isn't really in the common oxyanions that you deal with is the nitrate group and of course the bicarbonate. They're both -1. So we see in order to balance this, then we need to place a 2 here by the potassium. All right, we'll write a 2 there, so that gives us 2 times +1, which is +2, plus -2 gives us 0. Everything's balanced there. So the formula for potassium sulfate is K2SO4.